This is section 11.5, base E and natural logarithms. So log, we know the log that's built into the calculator has a base number of 10. There are a lot of other base numbers that we can have. One of them is known as E. E is known as our natural base. It's known as our natural base because the value for E, which is approximately 2.71828, and it goes on forever, that value is found all over in nature as different proportions. So here, our exponential function with E would be y equals e to the x. And log base E of x is equal to ln of x, where ln is known as the natural logarithm. So if we want to flip-flop and go back and forth in between these two, we can use y equals ln of x is the same exact thing as e to the y is equal to x. Notice that this is the same way how we went back and forth between regular exponentials and logarithms, where your base number on your log should be your base number with your exponent. Your base number on the natural log is e, so e is the base number on your exponent. So what we're going to do for starters is we are going to write the equivalent exponential or logarithm equation. So example 1, we have e to the x is equal to 23. So this is currently written as an exponential. So we want to rewrite it as a logarithm, more specifically as a natural logarithm. So your base number here is e. Since the base number is e, that means we are going to take the natural log. So ln, we're going to take the natural log of 23, and that should be equal to x. So we are flipping between the two forms the same way how we flipped in between the forms of logarithms. Number 2, ln of x is approximately 1.2525. So we want to write this as an exponential. So we first have to decide what our base number is. Since we have the natural log, we know our base number is e. So we would take e to the 1.2525, and that should be equal to x. This also illustrates exactly how we are going to end up solving these equations. And solving these functions is because we can then get x alone. So we're going to use our calculators to evaluate each expression. Now, this is a new button for us on our calculator, so I grabbed an image of the calculator offline so I can show you where the correct button is. This is the one that most of you are using, but this general form also corresponds with the other calculators. The values are in the same area. So on your calculator, you want to find the natural log button, the ln button. On most of yours, it's located right here underneath the log button. If you have those black calculators, it's right to the right-hand side of your log button. So if we want to take the natural log of something, that's going to be the button we use right there. Okay. Now, if you look at this a little bit closer, the value written in light blue right on top of it is e to the x. So in order to figure out what e to the 0.5 is, you would have to use that e to the x button. So for you with this calculator that we have up on the board right now, you would type in second e to the x and then 0.5. And when you do that, you should end up getting 1.6487. and we're always going to go to the 4 decimal places. If you have the black calculators, the smaller black ones, you have to work in reverse order. So you would put your 0.5 in first, and then hit your e to the x button, your second ln button. All right, so number 4, evaluate the natural log of 3. All the natural logs, we have to use our natural log button, which we already know is right here on our calculators. So you just have to hit the natural log and then 3. Doing so, you should be able to get 1.0986. If you have the black calculators, you would hit 3 first and then the natural log button. I want everyone to make sure that you can actually get these two values. So if everyone has not done that, please pause the video right now and wait until everybody has figured out how to use their calculator correctly. Please help your neighbors if they have not been able to figure it out. Okay, now we'll do some more examples. We want to evaluate each expression. E to the natural log of 21. Well, this is currently written as an exponent, so we're going to rewrite it as a natural log. Our base is e here, so we would have the natural log of whatever it is supposed to be should be equal to the natural log of 21. Well, of course, whatever that should be then should be 21. Notice this is pretty much the exact same as our problems with logarithms. When we had the exponent and then the base number of the log matching, we always would just have whatever was left on the inside. Number 6, same type of thing. We could actually do number 6 two different ways. We could rewrite it as an exponent and get something similar to 5. Or, because this is an exponent, we've already learned properties of logarithms. That drops down out in front. So we'd have x squared minus 1 times the natural log of e. Well, we know the natural log of e has the same base number as number. They're both e's. So that's just equal to 1. So that would just be x squared minus 1. All right, so now we are going to solve. So to solve, our goal is going to be able to get our e to the x alone or our ln alone first. Okay? So we want to get either, if we start off with the e to some sort of power, we want to get that alone. If we start off with a natural log, we want to get that alone. So number 7, we have 3e to the negative 2x plus 4 is equal to 10. So we first want to get the e to the negative 2x alone. So we'll start off by subtracting 4 from both sides of the equation. We now are left with 3e to the negative 2x is equal to 6. Next, to get the e alone, we can divide both sides by 3. We now have e to the negative 2x is equal to 2. Now, the negative 2x is currently in the exponent. Well, we can use properties of logarithms to bring exponents down out in front to end up multiplying. Since our base number is e here, we are going to now take the natural log of both sides. So we have the natural log of e to the negative 2x is equal to the natural log of 2. Our properties of logarithms tells us that this exponent get multiplied out in front. So we have negative 2x times the natural log of e is equal to the natural log of 2. The natural log of e is just 1. So we have negative 2x is equal to the natural log of 2. And then we would divide both sides by negative 2. So in your calculators, you would have to do the natural log of 2, so use your natural log button. And then once when you've done that, you want to divide by negative 2. So, provided you did that correctly, you should have an answer of negative 0.03. Nope, there should not be 2 zeros in there. Sorry about that. Your answer should be negative 0.3466. Make sure that you are able to get that correct answer and use your calculator correctly. Okay, equation number 2, or equation number 8. We have the natural log of 3x is equal to 0.5. So once again, to solve these, we need to either get the natural log alone or the e alone. Currently, the natural log is already alone, so we're set. So what we want to do is we are now going to kind of do the opposite of what we did before. We know that if we have e to the natural log of something, we just get that something back. We discovered that in example 5. So what we're going to do is we are going to take e to the natural log of 3x and make it equal to e to the 0.5. If the two things started off equal, they certainly are still equal when they're in the exponents, as long as we have the same base number, which we do. Well, e to the natural log of 3x would simplify down to 3x for the same reasons why in example 5, why e to the natural log of 21 equals 21. So here we have 3x equals e to the 0.5. And then to get x alone, we could just divide both sides by 3. So once again, you're going to have to use your calculators. Here you'll have to use your second ln button to get that correct. Okay, so you'll take e to the 0.5 and divide it by 3. Provided you did that correctly, you should get an answer of x equals 0.5496. That is 0.5496. Make sure you are able to do that correctly. Okay, we have a couple more examples for solving. Number 9, we want to solve the natural log of 2x minus 3 is less than 2.5. So we want to get the natural log alone, and it is. So since it is already alone, we are going to make those the exponents of e. So e to the natural log of 2x minus 3 is less than e to the 2.5. E to the natural log of 2x minus 3 simplifies down to 2x minus 3 is less than e to the 2.5. Now we want to solve for x, so we would add 3. So now we have 2x is less than e to the 2.5 plus 3, and then divide by 2. So you have x is less than, in your calculators, figure out what e to the 2.5 is first. Add 3 onto it. So that top portion, you should get about 15.1825, and then divide it by 2. So you should have 7.5912. So x is less than 7.5912. You certainly can put this entire expression into your calculator, provided you have the parentheses around the numerator. As long as you have the parentheses around the numerator, it should work out perfectly. And we will do one final example. Example 10. We have the natural log of 5x plus the natural log of x is equal to 7. Notice we have two separate natural logs here. We need to make them 1. So we're going to use our properties of logarithms to do so. Since they are adding in between, that tells us that we would multiply them. So we would have the natural log of 5x times x. or the natural log of 5x squared is equal to 7. Once again, we could now put those values in the exponent of e. So e to the natural log of 5x squared is equal to e to the 7th. This simplifies down to 5x squared is equal to e to the 7th. Divide both sides of the equation by 5. So if you take e to the 7th and divide it by 5, you have an x squared value of about 219.3266. So that's what x squared is equal to. So then we need to take the square root of both of those. When we take the square root, we would have plus or minus 14.8097. Since our natural logs cannot be taken of a negative number, the negative value here would not work. So our only solution that would work would be 14.8097. All right, so that is our section on natural logs and base E. There is one other way to view solving these. So if you are having trouble with how to solve these, I would going to encourage you to watch the next video. It is labeled Part 2, an alternate way to solving. And I will show you another way how to solve these without needing or without thinking of putting them both in the exponent. It works just as well. This is the method that I preferred, so I thought I would show this method first.